efficiency and effectiveness of fields. Come on. Leave aside the previous one. Leave enough space for you to solve that problem or any other problem. And come here. Now, efficiency and effectiveness. Do you see any difference between the two? Or both convey the same meaning? Let me have a poll. How many of you think, in the general context I am talking about, both are the same? Please raise your hands. Efficiency and effectiveness convey the same meaning. Raise your hands. No. Please raise the hands if you think they differ. If you think efficiency and effectiveness are different, please raise. The raising hands for none of this means what? No idea. Get an idea. Now I am talking about, forget about the things. General context I am talking about. In our day-to-day life usages or life situations. Efficiency and effectiveness. See, there is a big difference. There is a very big difference. Please listen. See, efficiency is a measure of how well you do a given task. Whether the task is useful or not to you or to the society, that is out of the scope of this. Just do what I say and that's it. How well you do it. For example, in order for you to understand it better, let's say, right, you have asked a team of laborers, 10 people, and a manager is there for them, supervisor, and you send them to your agriculture field. Right? The task given is you should dig a hole, right? Either to get water from it, right? Or let's say borewell, or maybe to plant a tree, or maybe the basement of a building, whatever it is. The task is dig it out. And the task given is very clear, specific. I want the diameter of that hole so and so, depth of the hole so and so, and you should complete it by the time I come there, 12 noon. You go there by 8 o'clock, 12 noon I will come. Well done, right? He went to 11:30 there, and then everything is done as per his instructions. Then they are efficient, right? That team is efficient. That supervisor is efficient. But unfortunately, they crossed the boundary of that land and dug it in the neighbor's land. Now you tell me, what is the use of all the work that they have done? Right? So the purpose is not served. They are efficient at the task that is given to them. But did they, do anything that is useful for that? No. You have to simply close it down and then come back. You can take any example. You want to become a doctor or a cricketer. Now coming here, sitting in the classroom, scoring 100 out of 100 in heat transfer. You are 100% efficient here. Right? Seriously, I am telling you. But your career is becoming a cricketer. Right? Will it help anyway? Will you be selected for coming IPL based on your heat transfer score? It will not. It doesn't work simply. So this is effectiveness. So now you can put this, right? Like if you want to put it in terms of words, efficiency is doing things right. When I say things, doing the given task perfect. That is the efficient. Now my task here is I am giving you study well and get, because that is my scope. Right? Whether that is useful or not, that you have to decide, that comes this. And now effectiveness is doing right things. There is a big difference between them. If you want to become a doctor, what is the right thing for you to do? Not to come here. Go somewhere and pursue it. That's the right thing. Right? But once you come here, you have certain tasks, right? And then you have to do it right. Are you getting me? This is the difference between efficiency and effectiveness. Please make a note of it in your own words. You can give your own examples. Come to the fin part. Now you tell me, what is the purpose with which fin is designed or created or installed? What is the purpose? Right? Idea is to enhance the heat transfer rate, not just to transfer, to enhance the heat transfer rate from the base surface. Now, fin, whether it is doing whatever it is capable of, is it working to its fullest potential? Right? If it is so, we call it as 100% efficient. The same example I am taking. Right? You have an opportunity to score 100 out of 100. So your maximum possible efficiency is 100. You may get 0 or 20 or 30. If you get 60, I am saying you are 60% efficient. Right? Now, what is the maximum possible heat that it can, dissipate to the surroundings? That is the denominator. What is the maximum possible marks that you can score here? You can't score more than 100, right? So 100 is the denominator. What actually you score, that is the numerator. What actually transfers is the denominator. What it can do maximum is the denominator. What it is doing actually is numerator. So that is applicable to you in a subject as far as marks are concerned. So it is denoted as efficiency of fin beta is Q fin actual. In a given situation, how much it is transferring or dissipating to the surroundings, divided by what is the maximum possible heat transfer. Right? So this is defined. This is the definition of the efficiency of heat. Now, let's take this case. This is the fin. What is the heat transfer rate from this fin to the surroundings depends on what? HA delta T, right? General thing. HA delta T. Delta T is temperature of fin minus temperature of surrounding. Surface area is area of the fin. Let's say even you can write this as area of the fin. Now, area of the fin, anyway, you know this, right? The surface area, perimeter into length, you will get. Heat transfer coefficient, it's a fixed, right? There is temperature difference, T fin and T. P infinity is also fixed. Now, what is variable here? This is variable. Is it variable or fixed? Temperature. How can you say it is variable? Its value is TB here. And as you move away from the base, is the temperature of the fin increasing or decreasing? Temperature of the fin at x is equal to 0, that is the base, is TB. And as you are moving in the direction of x along the length of the fin, is the temperature increasing or decreasing? It is decreasing. What is the lowest possible temperature of the fin at any point? That of the surroundings. So which is obtainable if the fin is assumed to be of infinite length. So now, when this can be maximum, see this is two phase. When can this be maximum? All other are fixed, right? T infinity is fixed. AS is the given dimension, it's fixed. Heat transfer is it's a property. It's not exactly property. It's a composite property rather. It depends on many things, which we will come to know in heat transfer when we see the convection part of the heat transfer. And now this will be maximum only when if and T fin is maximum. Right? Now what is the maximum possible value of T fin? T. That's it. So therefore this you will get when the fin temperature of the fin is equal to temperature of the base surface. That is the maximum possible. So with that case, suppose if you take case 1, long fin, very long fin. So what is the actual heat transfer? Square root of HPKAC into TB minus T infinity divided by. So what is the fin heat transfer from the fin when the temperature is TB throughout? Heat transfer coefficient into its surface area. What is the surface area? Perimeter into length, right? That is surface area into next comes what? T fin minus T infinity. But what is T fin? TB minus T infinity. So here TB infinity gets cancelled, right? So what is the remainder of this? Suppose numerator I write this as square root of HP into square root of KAC divided by this H into P. I will split into two terms. Square root HP, square root HP into L is a separate term. So again you can cancel out one of these, right? So what you have here? Square root of KAC by HP into 1 by M. Now, what is the square root of KAC by HP? 1 by M. So 1 by M into 1 by M. 1 by M. So this is the expression for efficiency of a long fin, right? Case 1, very long fin, not just long, very long fin. Efficiency is this. Please make a note of it. Wherever required. Don't simply copy this. You will later get all the doubts about it. It is defined as the ratio of actual heat transfer from the fin to CO2, the maximum possible heat transfer from the fin, comma, when the entire fin is at base temperature, base temperature. T of fin, T fin is equal to the T fin maximum is equal to TBN, right? Maximum possible value of shark fin of finite length with insulated ends. What is the equation? Case 2. long or short? So what will be the numerator for case 2? Into tan HML. So ఏమవుతుంది దీనికి ఎక్స్టెన్షన్ ఏమొస్తుంది ఎక్స్ట్రా tan HML by QML. Efficiency of it is tan HML by QML. Is it for case 3? Right. Efficiency is tan HMLC. See, between case 2 and case 3, just replace L with LC. HMLC by HMLC. LC is corrected length. Now let's look at effectiveness, right? Now see, applying the concept that we learned earlier. The question here is, why is that fin has come in its place? Where is the necessity to bring this fin? Right? See, it's a kind of occupies more space, more cost, right? No more weight. These are all liabilities, right? Whenever see, why do we, design something? What is the important design feature of anything, any product that you do? Is low cost, low weight, and more durability. And then anything you take from the cloth, from the pen, right? From the camera, anything you do. Design or innovation in design is constantly. See, engineers are there much before us. 100 years, 200 years, 300 years. You are studying here now after 200 years, let's say. Still there is IC engine. Same 2-stroke, 4-stroke engine is there, right? So same connecting rod, piston, or crown, or cylinder, or every part is there. But why is that? Again, you and then your juniors, thousands, lakhs of people are studying same mechanical engineering, right? Once it is invented, we can just keep it aside. Why the world needs us? Because it's a continuous process to reduce the cost of the machine that you are going to make it lighter, and make it work for more time. These are the 3 fundamental objectives of any design, right? So please understand this. Whatever you do, it must get smarter, right? Smarter in the sense you should have all these features. And now, more importantly, it should be doing less and lesser harm to the nature. It must be environmental friendly. That's the additional design feature or requirement that has assumed greater significance now. That was not there probably when originally something was invented way back. But now you might have seen the vehicles you call BS2, BS1, BS2, BS3, BS5, which is running now. BS6. What is BS6? Bharat standard, right? Emissions, slowly diesel engines are phased out. Why? Because it's difficult to meet such stringent emission norms in diesel engine compared to petrol engine. I think, have you studied IC engines, IC engine combustion, how the exhaust gases comes out, what are the reasons for pollutants that come out of the engine along with the exhaust gases? You all know this. So you have see here. Sometimes what happens, the other 3 objectives that I told you, right? Lighter, cheaper, and then durable, more durable. Sometimes may have to be compromised in order to meet the 4th requirement. So you may have to install one new equipment, new component to filter out those exhaust emissions to reduce them. Isn't it? See, it is simple like there is an IC engine which is releasing gases now. Now that smoke is coming around that lab and you and I are then breathing in. So what you need to do, you need to put an exhaust pipe long enough so that it goes out, up and again into the atmosphere. But that is additional component, right? That is increasing the cost, that is increasing the space, right? So, but unfortunately, you are helpless because the fourth point is also an important output. So, this is how the engineer actually works on the field. Now, the same thing applies even for a fin. Why fin has come in the first place? To enhance the heat transfer rate from the base surface. Without the fin also there is heat transfer rate. Now the question is with fin, whether by adding the fin, whether it is resulting in enhancement of heat transfer or not, right? So that is the effectiveness, right? So effectiveness of fin E is defined as what now, right? Q with fin, right? Whatever the heat transfer that is coming by adding fin to without fin. And then, see, there is a base surface, right? There is a base surface like this. Okay. Now this base surface is, this entire area is available for heat transfer without fin. Now I am adding a fin, or I am adding multiple fins, let's say like this. Now the heat transfer from this entire fins, right? Only fins, these are detachable, let us say, is the numerator. Now if I remove this, what is the gain I am getting here without fin? The base surface that is covered by this. Once it is covered, what is the loss for me? See, once the fin is attached, there is loss as well as gain. Right? Gain is the extra area that is available for heat transfer. ఇది కాకుండా మిగతాది ఉండేది రెండు కేసుల్లో ఉంది. విత్ ఫిన్, వితౌట్ ఫిన్, దెర్ ఇస్ సమ్ కామన్ ఏరియా. దాని గురించి మనం మాట్లాడలేదు. ఇప్పుడు నౌ లెట్ us take the case of only the effect of this fin. When fin is inserted, the advantage that you are getting is this extra area. But the disadvantage is it is blocking this base area. Right? There is no heat transfer from it. So therefore, the advantage should be more than the disadvantage, or they should be overcompensating the loss. Your gain should overcompensate the loss. So, for it to be effective, now you tell me, what should be the value of E? Shall it be less than 1 or equal to 1 or greater than 1? It must be obviously greater than 1. Right. Effectiveness of the fin is defined as the rate of heat transfer from the fin to the rate of heat transfer from the base surface without the fin. Without the this is like this. E is equal to fin by 2 without. This is simple, right? Please listen here carefully. Suppose now we are taking case 1. Listen here. Listen here carefully. Case 1. For case 1, I am writing the expression for. So now what is numerator? What is Q fin? Square root of HE JAC into TB minus T divided by. Now, in the absence of fin, without fin, remove the fin. Now, what is the gain you are, making in terms of additional area? It is detached. Let's assume this is pasted with gum, right? This fin is pasted with a gum. When you remove it, still that gum mark left by the gum is visible, right? Now, what is the area of that mark? What is the area of that mark? You attach something and remove. What is the mark that you have on it? What is the area? Huh? For this one I am asking. Simply it is AC. Am I right? This is the mark that appears here. So therefore, heat transfer from that surface is heat transfer coefficient into area of the base surface occupied by heat. What is that? Area of the base surface occupied is equal to AC. Rather, మీరు లేదంటే ఒకసారి ఏరియా ఆఫ్ ద బేస్ సర్ఫేస్ ఇక్కడ రాయొచ్చు వన్ మోర్ టర్మ్ ఇది నెక్స్ట్ టర్మ్ రాయొచ్చు రైట్ ఇంటూ నౌ దట్ ఈస్ అట్ కాన్స్టెంట్ టెంపరేచర్ why we have derived such an equation in the previous case, because the fin temperature is not constant. You can use the equation HA delta T Ts minus T infinity only if Ts is constant, but in the fins Ts is not constant, it's a variable. That's why we derived those equations. Now from the base surface, in the absence of fin, the temperature is constant, so therefore directly HA delta T you can use H into AB into what is the temperature here? It is TB minus T infinity, right? So in the next line, here in this line, TB minus infinity, TB minus infinity gets cancelled, right? The next step it is square root of HPKAC divided by H into AC, since this is what it is. Now you can write H AC, H into AC. H into AC, H into AC. Root HAC, root HAC. So what do you get here? Square root of K into P divided by H into AC. That is the expression for effectiveness of the long, very long case 2 effectiveness is denominator, will there be any change? No. Numerator, what do you get? Into tan HML. So this square root of AB by HA is there anyway, right? Into tan HML. If it is case 3, it equals same LC.